So 5-a-day maths, question 3 now. We've got to get our walkers back to their starting point. Obviously this is a group that were walking before the lockdown when it was still okay to go out in groups. We can't do that right now, can we? So the first thing I've done here is to draw a diagram of the routes taken by the walkers. They start off at the point P here, and they go on a bearing of 83 degrees. So they go off in this direction, and they travel for half an hour, reaching the river at this point here. Then they go on a bearing of 192 degrees. We measure bearings clockwise from north, so that's why this angle here is 192. They go then on that bearing to this point where the leader decides it's time for a rest, and that's basically the information on the angles from the question. The important thing to consider next is, how do we find the angles A and B? Well, if you look at angle A and this angle here, 83 degrees, they both add up to 180 degrees. They're what we call supplementary. So that means A is 107 degrees and then B is 71 degrees, because A, B and the angle 192 add up to 360. Now what I want to do is to find the lengths of the sides of the triangle. So first, the leg is travelled at 1.2 meters per second and for half an hour. So we can work out how many meters that is by using our equation for distance equals speed times time. So as you see there, on the first leg, the speed is 1.2 meters per second times 30 minutes, and then I want to convert that into meters, so I have to multiply by 60 to get a total distance of 2,160 meters. And then on the second leg, a similar calculation gives me the distance of 2,640 meters. So the next thing I want to do is, with the information I've got here, is to find the length of the third leg of the journey. So if we call the length of the third leg D, then how are we going to set about calculating D? We've got a triangle here, we've got two of the three sides, we're trying to find the third, and we've got the angle there, 71 degrees. Well, that to me looks like the cosine rule. So sure enough, the cosine rule applied to that triangle, D squared equals 2,160 squared plus the other side squared, etc., etc. When we square root, we get that figure for D. What we want to now do is to find the time that it takes for the walkers to travel that distance. So time equals distance divided by speed if we've got constant speed. And so the speed on the final leg is 0.9 meters per second. That gives us a number of seconds of 3,127, which is around about 52 minutes. So now we can, we've got all the information to answer the second part of this question now. What time will they arrive? So they start off at 9:45. The first leg is a 30-minute journey. Second leg is 40 minutes. Then they have their 10-minute break, which they're probably well ready for by then. And then it's 52 minutes, final leg, to get back to their starting point at 12:07, just in time for lunch. We've still got a bit more work to do, because we've got to find out what bearing they need to follow to get back to the start point. And at this point now, they're here. And of course, from this point, north is directly up the page. And so the bearing that we're trying to calculate is the following. If north is directly up the page, then the bearing measured in a clockwise direction from there is this angle C. We can calculate C very easily if we know the angle E. So how about finding out the angle E then? How do we do that? Well, when you look at this angle that I've written here, the angle 83 plus D, that angle is supplementary to E. So that means that that angle 83 plus D and the angle E together add to 180 degrees. So if only we could find the angle D, then we'd be able to calculate the angle E. Now, how do we go about finding the angle D? Well, if we look at this triangle, D is opposite that side, which we know, and we've got angle 71, which is opposite this side, which we now know. Looks like a case of the sine rule to me. So when we apply the sine rule, we get sine D over 2640 is equal to sine 71 over 2815. And that means that D is 62.47 degrees. Then we can calculate E to be 34.53 degrees, C to be equal to 325.47 degrees. So how did he get on with that question? Quite a long question, lots of problem solving there to do in order to find the final answers, both for time and for the bearing. Lots of care needed with the angles, and a good clear diagram also helps with a question like this. So if you got the same answers as me, great, well done. And let's have a look at the next question.